Attention mechanism. In the previous topic, you guys have got to know about how LLMs actually generate text, right? So, attention mechanism is one of the techniques which is used within that specific module. It is also used within that specific module for the generation of the text. So, we'll get to know more about it now. Hmm. Can you see my screen? Within the given screen, you can see one image to the left and another text over to the right. Can anyone uh, tell me what they have understood from this? Akash, can you look over the text if anyone is saying something? Okay. So I'll give you a real-time example. So suppose you are in a mall and you are trying to find your friend or family member in a crowd of people. So you're going to have your attention spanned over a limited focus, right? Like to a specific person, right? So in the same way, when it comes to AI, when it comes to large language models or any other application which we are using the attention mechanism for, when we have a sentence, like for suppose when we are feeding an LLM a sentence, within that sentence, the with the attention mechanism, the focus will be on a specific part of that sentence. It won't be on the complete sentence. As you can see in here, in a sea of data, machine learning models must develop the exact same selective focus. As because you'll get to know why we require it in the upcoming slides. The mechanism of old architecture. Like in the previously, before this attention mechanism architecture is developed, LLMs used to understand text in this way. Like when we give a input to an LLM, or when the LLM is training in a corpus of data, it used to train the data by going over the text token by token in the sense word to word, and I mean by dividing the sentence into tokens, into specific parts, you could say those are called as tokens. So that sentence will be divided into tokens, and it will go over token by token. So what happens actually with this part is that it becomes very slow. Like for suppose when you have a large amount of data, and for going over sequence to sequence by one token to another token in a particular sequence, it will take a lot of time, and it will also take a lot of computational resources. And another point is that like this type of architecture works when there is a limited amount of data. Even though it takes some time, it works pretty well for good amount of data. But when there is a large corpus of data, then when the model is going over the sequence to sequence as it goes forward, it tends to forget. Like there is a lot of probability of forgetting the previous data within the long sequences. That is the main problem which has been occurring within the old architectures. And the other point is that all the past information is compressed into a single fixed size pipe. So there are limitations to this type of model. As you know, long sequences it goes for. I mean, it tries to go over each and every word, as well as there is no contextual understanding, like making the whole corpus into a particular global context. There's no such feature within the old architectures, which takes a lot of computational resources, which can forget the previous um, context within the previous. I mean, within the long sequences. So now we'll know what is the difference between attention models and the older sequences. As I have mentioned before, the older sequences are based on sequential modeling, sequence to sequence, word by word, which takes a lot of processing. And the attention mechanisms, when we input a text, all the inputs are processed simultaneously. It works in parallel processing. And because all the inputs are processed simultaneously, it is faster, way faster compared to the sequential modeling which the previous models used to have. Compressed bottleneck, high information over distance. When there is a lot of when there is a lot of information which needs to be processed, it causes a lot of bottlenecks. But when it comes to attention mechanisms, there is a global context. Like when even when there is a lot of data, a large amount of corpus of data which needs to be processed, as there is a global context, which is the understanding of the total sequences, there will be no loss to the past data. Word distribution. Previously, in the older sequences, all the parts of the sequence, like all the tokens, are given the same importance. Like, for suppose, I'll give you an example. Like, I went to a shopping mall, or Akash went to a shopping mall. Here, Akash and shopping mall are more important when compared to the rest of the tokens, rest of the words within the same sentence, right? Like they should be given more importance as they are the subjects. Okay. So, but that isn't happening within the previous models. But when it comes to attention mechanisms, we are going to have a weight defined, dynamical weight defined for the tokens within the within the sequence or within the sentence. It would be in such a way that the higher importance tokens will be given more weightage compared to the others. This is done by mathematical processing. As in the previous session, as Akash has mentioned, there will be a, as you know, these weight distributions or probability distributions all works based on mathematical formulas, everything which is based on mathematics. Attention acts as a dynamic highlighter. As you can see within here, the models which has attention mechanism technique look at the sequence simultaneously. Like all the words within the token, I mean within the sequence, are looked over at the same time, and the higher importance one are given the higher weightage. There will be a relevance score given to the surrounding piece, every piece of data. Relevance score in the sense which is more relevant to the what we ask or to the particular sequence. And another point is that shortcuts are built between the highly related concepts, regardless of the distance. Like for suppose, within the previous example which I have given, Akash went to a shopping mall. Akash and shopping mall will be interlinked and a shortcut will be formed between them because those are very highly related concepts. Even though there are a lot of tokens in between, there will be a shortcut which is built between them, which will reduce the processing time and also reduce the computation resources required for it. The query, key, and value framework. This is a framework which is used within the attention mechanisms, where the query means the input which we are giving the model. Like I need a book on machine learning. It's one of the examples. Like for suppose that is what the model is looking for. Like that is the prompt which we given the model, which is the query and keys. What when that particular query is given to the model, when it is looking for that, it labels the data which is relevant to it. Like it it require. I mean, what we have given is I need a book, right? So it needs to look upon the books and how we are going to look upon a book. Like for suppose when we call a person, we are going to call the person by name. In the same way, a book title will be more relevantized. So in the same way, first the labels will be attached to the book titles as well as the category because I need a book on machine learning. Machine learning is a category, right? So in the same way, category tags are also labeled. Those will be forming the keys and the value and the key which we are going to select, which the model is going to select, the value within the key will be taken. The text inside the machine book, matched book. Like for suppose when we ask the model, I need a book on machine learning. It checks upon the relevant titles, relevant category tags, and the most relevant machine learning book will be taken, and the content will be returned. That's what happens within. This is the framework which is used within attention management. Turning database matches into weighted focus. First, match, as you can see within the screen, match, score, weight, and combine. I'll give you an explanation on what each one is. Match. Match in the sense the query will be matched against all the keys to evaluate the relevance, to see how relevant are all the keys, are all the things which is being searched to the query. And after all the keys are compared, a raw similarity score will be assigned to each of the key. Okay, as we have mentioned in here, it is a raw score. The raw score need to be normalized. Normalized in the sense, like for suppose, mm, yeah, let's consider that there is heights where a person can be 150 centimeters tall, a person can be 200 centimeters tall, and we want it to be normalized for easier understanding, like between 0 and 1. That can be considered as normalization. It's one of the examples which I'm just giving. And when we get back to the topic, after generating a raw similarity score based on the math strength, these raw scores will be converted to percentages. And here the factor which is being taken is 100%. Okay, so what we do is after a raw similarity score is generated, that score will be weighted by using functions. The softmax which we can see in the screen with which is below the weight, that is an activation function which we use in neural networks. Activation functions are very relevant to the neural networks, which is like there are various different types of activation functions like softmax, tanh, etc. Combine multiple values by these percentages to output a unified focus vector. These values will be combined such that a focus vector is generated for returning the response. Resolving context to spatial mapping. As you can see in the example here, the animal didn't cross the street because it was tired. See, when it comes to a human brain, we are able to understand easily because of the our consciousness because of our consciousness which we have. We can easily understand what is the meaning of it here. It refers to the animal, but when it comes to the model, it wouldn't be able to understand in the same way because it doesn't have the consciousness which we have. It needs to understand based on the mathematical representations which we do. Okay, so what happens in this is through spatial mapping, the animal will be the model will be able to understand what it means. It means animal rather than something else within the same sequence. This will cause to reduce the grammatical ambiguity which the models can have, which used to happen within the previous architectures. It is all based on mathematical algorithms which you use within the attention mechanisms. Here we can see the two different types of architectures, two different types of techniques which we have within attention mechanism. One is self-attention and another is cross-attention. Self-attention means that the model analyzes its own sequence to understand internal context. So it doesn't evaluate against anything. It evaluates against itself rather than something else. For example, reading comprehension, understanding a sentence typed by a user, etc. Cross attention. Cross attention, as the name implies, the sequences within one would be compared with the other. The model looks at different sequence to align corresponding information. For example, translation. For suppose when you are translating from one language to another language, like for suppose we are translating from French to English, there we require the cross attention, where one sequence should be compared with another sequence. Attention mechanism all started from this particular paper. This is a research paper which has been introduced in 2017. Attention is all you need is a paper which has been released, due to which the researchers completely discarded the sequential RNNs. The previously I have mentioned that it used to completely work on sequence to sequence, right? Like from one token to another token. That has been discarded, and researchers and AI people have started to use attention mechanisms from them because I think it, as I have mentioned before, it has reduced a lot of processing power and the previous issues which the previous architectures used to have. the amount of time which it takes, the processing power which it takes is very efficient when compared to the previous sequential RNNs. RNNs means recurrent neural networks. Recurrent neural networks is a type of neural networks which is used for sequence to sequence type of data, like for text type of data. This shift unlocked a massive parallel processing, forming the T in the sense transformers. See, you might have been using ChatGPT, right? Chat GPT means generative pre-trained transformers. It's a type of transformers which is being used. But bidirectional encoding representational transformers. It's also a type of transformer. Gemini also uses attention mechanisms. It is built upon the attention is all you need concept. It based on that architecture. Gemini is also built. This particular attention is all you need paper became the foundation of our current era for the large language models. It's one of the foundations, powering the broader ecosystem of modern AI. It is attention mechanism is being used in various different types of fields, like natural language processing. When it comes to chatbots, when we chat with a chatbot like Gemini or ChatGPT or Grok, etc. Real-time translation. It is also being used for real-time translation, like Alexa, Siri, dynamic text summarization. Like when we are going to summarize any text, like when we upload a document or a PPT or a PDF to a ChatGPT and asking it to summarize it. It uses attention mechanism. Image captioning. Like for suppose you have an image which contains a dog, then it is going to label that particular that particular set of pixels. Pixels in the sense it is the fundamental block of an image. Those are what we call as pixels. So all the specific pixels of the dog will be considered as a dog. So it is also used for image caption. Like for suppose if you have a car with an image which contains a car, an image which contains a building, or those objects, the objects with an image will be captioned. Speech processing, voice assistants like Siri, Alexa, they're all it is also used for this, like because for suppose there is a lot of noise and the Siri or Alexa which we are talking to need to focus on our voice, right, ignoring the background noise. It made this particular aspect very efficient. That's it. Is there anyone who has any doubts? Akash, check over the chat. If you have any doubts regarding this concept or the previous concept which Akash has taught, you can ask us. Or suppose if you have any doubts regarding any particular aspect which we haven't taught, like uh, as you know, we are focusing on a particular topic, right? Like if you haven't understood something within which we have reference but has not explained because we do not have that much time for that for this session. If you have any doubts regarding it, you can also ask regarding those aspects too. Yeah, we are going to have these sessions, recorded sessions within the YouTube channel, and also these PPTs will be shared within the description. So you are going to have the both the recorded sessions as well as the PPTs. Okay then. Thank you, Zach, for joining the session.